Hey, so we're looking at a mixture problem. I'm taking it from the homework set number 4. So we have a salty goal at the start. We have 5 pounds of salt, which are dissolved in 20 gallons of water. And we have a salt solution with a concentration of 2 pounds per gallon, which is being added. It's being added at a rate of 3 gallons per minute. And then the well-stirred mixture is being drained out at the same rate of flow, right? So rate in equals rate out. How long should the process continue to raise the amount of salt in the tank to 25 pounds? Great, so something that I look at just to double check, is this possible where we have 2 pounds per gallon is being added, and since there's 20 gallons, yeah, that's possible to raise it up to that much. Okay, great. So what do we need? Well, let's think about, we call these X typically. You could call it a different value if you choose, but X is sort of our go-to. And so let's say, well, at time 0, we have 5. So X is always sort of the amount of salt, not the concentration, but the amount. And so it'd be X. The concentration here would be, 5 out of 20, but we just want X. And so we have a salt solution, which is being added. So let's talk about the rate in. We want the concentration, which is 2 pounds per gallon, and is coming in at a rate of 3 gallons per minute. So 2 times 3 pounds per minute. So 6 pounds per minute is coming in. And the rate out, well, the concentration is, well, it's X, right? X is the amount of salt, and it's divided by how big our tank is, X over 20. So that's the concentration out. And, well, the rate's going to be the same, right? It's flowing out 3 gallons per minute. So here we have 3x over 20 pounds per minute flowing out. So our equation looks like this. Maybe I should do it in a different color. So let's do it in blue. So the change of x with respect to time is equal to the rate in, 6 minus the rate out, 3 x divided by 20. So this value, notice, well, what does this mean? Well, there is a negative here. But while x is less than, while this term, 3x over 20, is less than 6, which means, well, x is less than whatever that needs to be, right, 40 or whatnot, then it is increasing. So let's find what we have. Well, to solve this, let's go ahead and come down here. I was hesitating. I'm going to write that initial condition once more as well. You can do one of two things. You can recognize that we've solved things like this before, or you can solve it directly from this equation. So if you recall, we often write it this way. Now, in this particular problem, so I often think about, since these are both constants here and here, the homogeneous solution, right? So x would be the homogeneous. Maybe we should color code them. The homogeneous plus the particular. So the homogeneous solution, if I had a 0 over there, x would be some constant times e to the negative 3/20th t. And the particular solution, you would add to that, what would x need to be to make this whole thing equal to 6? So x need to be 40. I believe I said that earlier as well. So here is our term, our expression for x, the quantity in terms of time. Now, in this problem, let's zoom up a bit. It said, how long should the process continue to raise the amount to 25? So to finish our solution, we say, well, we need two things. We need to plug in k and then ask, when would this be 25? So I jumped ahead. We need to use our initial condition real fast. So with our initial condition, so x of 0 gives you k plus 40, and we want that to be 5. All right, great. So if that's 5, that tells us that our k is negative 35. Yeah. All right, awesome. So this then is our actual x as a function of t. We have negative 35 this expression plus 40. Looks kind of like a fish. So now we get asked that follow-up question of such great import is, when is this 25? When is this 25 pounds? So we say, well, let's ask it. Say, dear Mr. Equation, when are you equal to 25? So set 25 on one side, and we have negative 35e. This expression is equal to negative 15. So let's keep simplifying this a little bit, maybe do it in a brighter color. So negative 15 divided by negative 35 is 3/7. So here we have negative 3/20. T is equal to natural log of 3/7. So as a final hurrah, we can say T then is equal to negative 20 over 3 natural log of 3/7. Allow me to pause the video while I stick that into a calculator to get an approximate solution. This gives us an approximate time of about 5.65 minutes here. So realize this looks kind of zoomed in. That's kind of bad form. So let's zoom out a bit and sort of look at what happened. So with this problem, we set out our problem by finding the initial condition. We found our rate in and our rate out. The change is the rate in minus the rate out. We solve that equation here. Stuck in our initial condition to get this expression. And then we had the follow-up. When is this equal to 25? So we just set it equal to 25 and then had to pull out our algebra skills to find T. All right, great.